Hi everyone, welcome back to my channel. So today we are going to talk about limit. Okay. So the limit definition says the limit of f of x as x approaches a equals some value, we're going to call it L. Okay. So the question is, what does it mean? Let's take a look at one easy example. Okay. So think of it this way. We have a function y equal to x. Okay. Um, we all know how to graph a function like y equal to x, right? We just need a t-table, x, y. We take bunch of values. So 0 will be 0, 1 will be 1, 2 will be 2. Once we find those points, then we can draw a straight line, right? So y equal to x. So that's how I have drawn the function, right? Now, let's say if someone asks me that if if f of x equal to x, if x is equal to 1, what's the y value? Okay. So what we do if someone asks you if f of x equal to x, x is equal to 1, what's the y value? One thing you can do, you can just plug it in. So f of 1 will be just 1, right? Remember, our y value is f of 1, right? So y is your f of 1. So in this case, the answer is going to be 1, isn't it? So the in limit, the idea is almost the same. Almost. Not exactly, but almost. All right, so let's say if someone asks me limit as x approaches a of, for this function, let's f of x equal to what? Okay, so let's say for this specific problem, my f of x is equal to y equal to x or x. Okay, and let's say my x is approaching some number, we can call it 1. So what do you think the answer is going to be? The answer is going to be 1, isn't it? Okay. So if x is 1, the y value will also be equal to 1, right? So what does that mean? So it means as x approaches 1, my y value is approaching 1. Okay, so that's what it means. As x value is approaching 1, the height or the y value is approaching to 1. Okay. All right, so this is the easiest example that I can give you. Let's work on a different example. Okay. All right, let's say I have y equal to x minus 1 divided by x square minus 1. And let's say for this function, I want to ask the same question, okay? Now, pay close attention. You have to listen really, really carefully because this part can confuse you. So I am going to talk about two different things, okay? So let's say if f of x equal to x minus 1 divided by x square minus 1. If someone asks me if for this specific function, if x is equal to 1, what's going to be the y value? Okay, so what's going to be the y value? So f of 1 is going to be 1 minus 1 divided by 1 square is just 1 minus 1. So that's just going to be 0 over 0, okay, which is undefined, okay. I hope you notice that we also have a small hole here, and that's why we found undefined, right? So if I ask you this question, this isn't giving us a lot of information about that about this graph at that specific point, right? So one thing we can do, we can use limit to find out what's going on around 1, okay? So what limit does, it does not care about what's going on with the height or the y value at that specific x value, okay? It only cares about what's going on around 1, okay? So that's why we use limit. So this is not useful, okay? So we don't want it. What we want to use limit. Okay, let me erase this part, okay? So now I'm going to ask the same question but using limit. So limit as x approaches 1, what's the value of x minus 1 divided by x square minus 1? So now what we want to do, we want to find out what's going on with the height as x is approaching 1, okay? So for limit, what you have to do, you should always simplify the function as much as you can, okay? So on top, there's nothing we can do. In our denominator, we have x square minus 1. That means we can apply the differences of perfect square formula, okay? If you do that, you will get x plus 1 and x minus 1, okay? So I have x minus 1 on top and x minus 1 in the bottom. They will cancel each other out. So we have limit as x approaches 1, 1 over x plus 1. Now you can plug it in. If we substitute x with 1, 1 plus 1, that's going to be 1/2 or 0.5. As you can see, we also have 0.5, okay? So I hope you noticed the difference between limit and finding out the y value when x value is given. So limit is saying what's going on around. So limit is basically saying what's going on around 1. It does not care about what's going on at 1. It cares about what's going on around 1, okay? So it's giving us the height or the y value when x is approaching 1. Hi everyone, welcome back to my channel. So today we're going to talk about limit part 2. Let's take a look at the example. The limit of square root of x plus 81 minus 9 over x as x approaches 0 equal to what? We want to solve this problem. Before I show you how to solve this problem, I want to talk to you about two things. Let's talk about the first thing is conjugate. Conjugate. So what is conjugate? The idea is simple. If you have a plus b, the conjugate of a plus b will be a minus b, okay? So let's say if I have x plus y, the conjugate will be x minus y. If you have, let's say, x minus 9, the conjugate will be x plus 9, okay? So you just change the sign, all right? The second thing that you need to know is called the differences of perfect square formula. The differences of perfect square formula. Okay. What do I mean by that? So the differences of perfect square formula says if you have a square minus b square, you can write this as a plus b times a minus b. Okay. Or if you have a plus b times a minus b, you can write you can write a square minus b square. Okay, so those are the two things you should know. For example, there's one more thing. I hope you notice that they are conjugate, right? They are conjugate. So if you have x plus y times x minus y, that's going to give us x square minus y square. Okay, so these are, we are multiplying by the conjugates. Okay. All right, now I think you're ready to solve this problem. Okay. All right, let me write it one more time. Limit as x approaches 0, square root of x plus 81 minus 9 divided by x. So whenever you have a problem like this, square root of something, then plus minus something, you should always think of multiplying by the conjugate. Okay, so that's exactly what we're going to do. Square root of x plus 81 minus 9 divided by x. I'm going to multiply top and bottom by the conjugate. Okay, so that's going to give us x plus 81 plus 9. I'm also going to divide by the same thing, x plus 81 plus 9. Okay, now what should we do? Now we are going to multiply the top number. Okay, so if we multiply the top, I hope you notice that they are conjugates, right? So we can apply the differences of perfect square. So that's just going to be square root of x plus 81 whole square minus 9 whole square. Okay, so we just applied the differences of perfect square formula. I already talked about it. So it's a plus b times a minus b equal to a square minus b square. Okay, now in our denominator we have x square root x plus 81 plus 9. So now you may be wondering, why didn't you just substitute x with 0? Well, we cannot do that because it's going to give us undefined. Okay, so the whole idea is we want to simplify it as much as we can so that we can get rid of the x that we have in our denominator. Okay, we want to get rid of this x. Okay, now let's see what we can do. Limit as x approaches 0. On top we have, well, the radical sign and the power 2, they will cancel each other out. X plus 81 minus 9 square is going to be 81. Now in our denominator we have x parentheses x plus 81 plus 9. So on top 81 cancel each other out. Limit as x approaches 0. So we have x divided by x, square root of x plus 81 plus 9. As you can see, we have x on top and x in the bottom. They will cancel each other out. That's exactly what we wanted to have. As approaches 0, we have 1 on top, square root of x plus 81 plus 9. Okay, now we can substitute the x with 0. Okay, so it's 1 over square root x will be equal to 0 plus 81 plus 9, 1 over square root of 81 plus 9. Well, square root of 81 is just 9, so 9 plus 9, that is 1 over 18. Okay, so I hope it makes some sense. Let me know if you have any question.